Hi everyone and welcome to the internet. So what we're going to do in today's lesson is we're going to be having a look at the electrolysis of molten salts. So hopefully by the end of this video then what you're going to be able to do is describe electrolysis and what reactions are occurring at those electrodes. Now what I've got for you first of all then is just a bit of a recap on some of the work that you would have done back in C2 about bonding. So you've got 3 questions there to have a go at. So have a go at answering those questions now, and I'm going to give you 3 minutes to have a go at that. Okay, let's check your answers then. Obviously, if you've got it right, give it a tick. If not, then give it a cross. So the type of bond that forms between a metal atom and a non-metal atom is an ionic bond, and the type of bond that forms between non-metal atoms is a covalent bond. Now for question 3, draw the dot and cross diagram of the bonding in sodium chloride. We're going to have a look at the actual diagram. Okay, so what we need to do to draw the dot and cross diagram for the bonding in sodium chloride is, first of all, we look up how many electrons there are on a periodic table. So you're looking at the atomic number here. Okay, so we've got 11 for sodium and 17 for chlorine. So that tells us sodium has 11 electrons, chlorine has 17 electrons. Now I've only just bought one of these graphics tablets and this is the first time I'm using it, so my drawing is probably going to be rather embarrassing, but you know, it should be good for a giggle anyway. Let's give it a go. So we're going to start off with our sodium. Now hopefully we remember that when we're drawing a dot and cross diagram, then we've got the electrons arranged into shells. So the one closest to the nucleus can hold up to 2 electrons. So we've got 11 to use, we've got 2 already there, so 9 still to go. So our second shell can hold up to 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Still obviously got one electron left. So we need our third shell, and we're going to put our one electron in. So there's our 11 electrons in sodium. Then we can do the same thing for chlorine. So over here, let's do our chlorine. So the shell closest can hold 2 electrons. Remember, we've got 17 this time. And because it's a dot and cross diagram, we've got to do these ones as dots. So still got another 15 to go. So here goes 1, 2, 3, 4, 5, 6, 7, 8. So that's 10 electrons so far. Need another shell. And then this one's going to have 1, 2, 3, 4, 5, 6, 7. So that's how it starts off. Now what we're actually going to see happening is that this electron here is going to be transferred over there. So what we actually end up with is the one electron from our sodium here gets transferred to the chlorine. So when we then redraw these, okay, here's our sodium. Now we've still got the 2 on the innermost shell. We still have our second shell, which has got the 8 on it. So let's just draw those in very quickly. But that outer shell electron has gone, so we don't do the outer shell. And then we put square brackets around it. And because we've lost an electron, that means there's one more proton in the nucleus than there are electrons now, so we give it a positive charge. Then we're going to do the same thing for our chlorine. So we draw it back again. We've still got the 2 on the innermost shell. Our next shell then has 1, 2, 3, 4, 5, 6, 7, 8. Our third shell has got the 7 it had originally. So put those little dots in. But it's also got the 1 from the sodium, which we do as the cross, because remember, the crosses are all the sodium, the dots are all the chlorine. So this time we've got one more electron than protons, so it has a negative charge. And that is how we've then got our bonding diagram. Now, before we can really go anywhere on this, we need to understand what the word electrolysis actually means. Now, electrolysis, if we're asked for a definition, is the process in which an electrical current is passed through a compound, causing a chemical change. Now, break the word down, because if we look at scientific words, there's quite a lot of logic in there. So if we break that down into the 2 parts, the first bit being electro, then that's to do with electricity. Lysis just means splitting. So we're splitting using electricity. Make sure you've got that definition written down in your books. If you need a bit more time, then obviously just pause the video. I'll give you just a few more seconds to get that done if you haven't already. Let's start off with the basics then. In order to carry out electrolysis, we need 3 key things. First one are 2 electrodes, which are made of either metal or graphite, and they're going to conduct the electricity to the electrolyte. The second thing is the electrolyte itself. Now, an electrolyte is a compound in a liquid state or a solution, and it contains mobile ions and conducts the electricity through itself. And the third and final thing we need is some kind of electrical supply, usually is in the form of a power pack for us. Again, make sure you've got those 3 key points written down. If you need a bit more time, then pause the video. I'm just going to give you another minute to get that done. Okay, before you actually think you need to draw the diagram in the bottom left corner, don't panic. What I've actually done is on my website, which I'll give you the link to at the end of the video, then I've put a version of that up there. So either you can draw it yourself if you don't have a printer later on, or you can just print it off and stick it in. Now, what we can see in that diagram is that we've got the basic setup of electrolysis. So at the top, we've got our power supply, as we already said. Coming off the two sides there, we've got our two electrodes. One positive, the other is negative. Now, what we find is the negative electrode is called the cathode. And I've given you the picture of the grumpy looking cat in the corner there to hopefully help you to remember that the cathode is the negative electrode. So negative cathode. The other one, the positive electrode, is the anode. So make sure you know the names of anode and cathode and what charges they've got on them. The other bit I've labelled on there for you are the names of these different ions, because in our solution you can see there are positive ions and there are negative ions. So the positive ions are called the cations and the negative ions are called the anions. So, question for you to have a go at then. Where do you think the names anion and cation come from? So have a look at the diagram, think about what we've just said, and then write your answer down in your book. Okay, so the next thing we need to do then is understand what is actually happening during this process of electrolysis. So when we flick the power supply on, what we're doing is we're splitting the chemical into positive and negative ions, and they're free to move. Now, hopefully we do remember the basics of charges. The opposites will attract. So the positive ions are attracted to the negative electrode and the negative ions are attracted to the positive electrode. So what we actually see then is, and you can see this in the diagram there, that our cations are attracted to the cathode, hence why we call them that, and the anions are attracted to the anode, hence why we call them that. Now, once those ions actually reach the electrodes, then they become discharged. So what I mean by that is they lose their charge. So the positive ions are going to go to the electrode and then they're going to gain electrons to become a neutral atom, whereas the negative ions travel to the anode, and where they reach that, what they do is they lose electrons to become a neutral atom. So when we're discharging them at the electrodes, they're either gaining or losing electrons. So make sure you remember positive ions need to gain an electron to make them neutral, whereas the negative ions need to lose an electron to make them neutral. Now that hopefully we've got a basic grasp of the process of electrolysis, what we're going to move on to is actually understanding how we can predict what we're going to make at the end of carrying out the experiment. So what we need to do first of all is consider something called a binary ionic compound. Now where we're talking about a binary ionic compound, this is something that's just got two elements, because binary, so bi, means two. So it's a compound that is obviously joined through an ionic bond, so it'll be a positive and a negative ion there, and there are just the 2 ions. So it's 2 elements. Now the example I've got here for you is lead bromide. So when we look at the formula there, you can see PbBr2. Now Pb is the formula for lead, Br is the one for bromine, so we've got our lead bromide there. Now, as we've already said, in electrolysis, what's actually going to happen is, as we turn on our current, then the electricity is going to split those 2 ions. So the lead is going to be split away from the bromide ions. Now, what we're going to do is have a look to see what happens at each electrode. So if we consider the cathode, and hopefully we remember the cathode is the negative electrode, then we are going to produce lead there. Lead, hopefully we remember, is a metal, so we find it on the periodic table towards the left hand side, so all the metals there. Now, because it's a metal, it's going to form positive ions. Therefore, it will go to the cathode, the negative electrode. So what I've got for you is the half equation for what's actually going to happen when those lead ions reach the cathode. So the lead ion is Pb2+, and when it reaches the cathode, it's going to gain 2 electrons. So 2 electrons are transferred from the cathode to the lead ions, and because obviously we've got that 2+ charge, we needed the 2 electrons. Once that's happened, we've made the neutral lead atom, Pb. The next thing that's going to happen is over on the anode. So the anode is our positive electrode, and our bromide ions are negative ions. So what we see happening here is the bromide ions are attracted to the anode because they're opposite charges, and when it reaches it, what's going to happen is the bromide ions are going to lose electrons, so the electrons are going to be transferred from the bromide ion to the anode to make bromine, and obviously we're going to have those 2 electrons being transferred to the anode. So our half equation there is 2Br- makes Br2 and 2 electrons. Now, one thing you should remember here is that whenever we're writing one of the halogens, group 7, then they always go round as a pair. So whether it's bromine, chlorine, iodine, any of those, they will always form Br2Cl2, I2, the little 2 in the bottom right. Because of that, in order to have it balanced, we need the 2 ions. So just make sure you go careful with that bit. Now, the key thing to remember here is that when these ions, whether they're positive or negative, reach their respective electrodes, then they become discharged. So they lose their charge and become either atoms or molecules. So make sure you've jotted down those key points in your book because they are very important for us. So let's see if you can have a go at this question then. Predict the products formed during the electrolysis of molten sodium chloride. So write down in your books, what products would we make when we carry out electrolysis of molten sodium chloride? I'm just going to give you about 30 seconds to do that. Let's check your answers then. Hopefully you've got written down sodium and chlorine. So those are our 2 products that we make there. The last thing we really need to consider then is what happens in terms of movement of ions. Now remember the title of today's lesson is Electrolysis of Molten Salts. Now something that's molten is in its liquid form. If we've got our liquid form of our salt, then what's going to happen is as those ions that are close to the electrodes become discharged, so they become their atoms or their molecules, then the concentration of ions by the electrode is going to decrease, it drops. Which means we're then going to have that movement of ions. Now, the other ions are going to move to replace them close to the electrodes by one of two processes, either diffusion or convection. Hopefully we remember from our biology work that diffusion is the movement of ions from an area of high concentration to an area of low concentration. So they're going to move obviously from where they're in higher concentration to the low concentration area near the electrodes, and then they get discharged. If we consider our salt as a solid, then this can't happen. Because thinking back to our work in C1, we know that the ions in a solid are held in these fixed positions. All they can do is vibrate around a fixed point. So if we're trying to do this to a solid, it can't work because the ions are not free to move. It's only when we've created the molten form of our salt that the ions are then free to move, that electrolysis can take place. Last thing we need to do today then is have a go at the plenary task. So you've got two sets of questions. If your target grade is up to a grade 5, so anywhere between a grade 1 and a grade 5, have a go at the questions on the left. If your target grade is a grade 5 to 9, anywhere within that bracket, have a go at the questions on the right. Now, what we're going to do is just give you a few minutes with those on the screen so that you can actually have a go at answering those in your book. And don't just stop the video now. The whole idea is that you actually have a go at these to see if you know how to do it. Obviously, if you get stuck, then ask the question in the chat window and therefore I can give you a hand with it. So to get the answers to those questions rather than going through them here, then I've put them up on my website. So the link is on your screen now. If you go there, click on the tab that's got Internet School on the far right, and then you'll be able to find the answers to today's questions. In addition to that, I've put up some more questions for you to have a go at before our next lesson. So hopefully you found that useful today and you've actually made some good notes. Remember, if there's other bits that you still need, you can always rewind the video. It will be on the website. And of course, don't forget to join us again, same time on Wednesday for our next combined science lesson.